This problem is asking us to find conditional probabilities, in this case from a two-way table. Before I start with these, I always like to total up my marginal columns, my marginal totals, just so I know how many people are involved inside of my scenario. So in this case, we have males and females either playing sports or not. And so among the males, it looks like there's a total of 30 males, and then there's a total of 20 females for 50 people altogether. And then as far as sports go, it looks like there's 23 playing sports and 27 not playing sports. Now, I'd like to double check that, make sure that I do have a total of 50. So then when we want to find probabilities from this chart, for example, the probability of being a male would be looking at all of the males, which is 30, out of all of the people, which is 50. So the answer there is 30 out of 50, or 3 out of 5, or 60%. On the other hand, if I want to know the probability of playing sports and being male, then I'm only looking at the slot that is talking about males playing sports. That's only 12 still out of the 50. Now the conditional probability, that's what this bar right here means, that's read as the word given. This is saying the probability of playing sports given that you already know the person is a male. So in this case, the denominator changes. You're not talking about all people, you're only talking about the males. And so the denominator, instead of being all 50, is just 30. And then you can look at the probability of being in the sports if you're males, and that's a count of 12. So the answer to the conditional probability is 12 out of 30. And one interesting thing to note by the end is that that's this number over this number. So finding the probability of being in sports given that you're male is the same as the probability of being involved in sports and being male, but only being divided by the probability of being male. Okay, hopefully that made sense, but let's give us a chance to follow up then. Try to do this problem down here with parents and students buying sweatshirts and t-shirts. And assuming you paused the video and tried this on your own first, let's now do it together. So like before, I'll add up my totals. Let's see, the total number of parents is 8 and 18 for 26. And then for students, it's 24 and 30 for 54. So it looks like there's a total of 80 people. Let's go see if that's consistent with the other side. 8 and 24 is giving me 32. 18 and 38 is giving me 48. And yes, indeedy, that is 80. So the probability out of anybody getting a sweatshirt is out of the total of 80, and then looking at the sweatshirt total, which is 32. That's a 32 out of 80. On the other hand, of everybody out of 80, the probability of being a student and having a sweatshirt as your choice is just that selection. So that one's going to be a 24 out of 80. And then finally, if we look at it from the student given sweatshirt, that means we are only looking at the people who got sweatshirts. So the people who got the sweatshirts, only the people who got sweatshirts were the total of 32 people. And out of just those 32 people, 32 of those sweatshirts, 24 were selected by students. So the answer there would be a 24 out of 32 for the conditional probability at the end. And barring any simplification, this is the answer to the question. Hopefully you got the same.